There is a coastline in Victoria that most Australians think they have already seen. The photographs. The tourism campaigns. The iconic image of limestone stacks rising from the Southern Ocean that has appeared on more postcards, more screensavers, and more travel magazine covers than almost any other Australian landscape. The 12 Apostles on the Great Ocean Road west of Melbourne is one of the most visited and most recognized natural landmarks in the country. Most of the people who visit it stand at the cliff edge lookout, take photographs for 20 minutes, and drive on toward Port Campbell or Loch Ard Gorge or wherever the itinerary takes them next. What almost none of them know is what the scientific investigation of this coastline over the last 2 decades has revealed about the rock, the ocean, the biology, and the human history of this specific section of the Victorian coast. Because when researchers stopped treating the 12 Apostles as a scenic backdrop and began treating it as a scientific subject, what they found revised the understanding not only of this site but of the processes that shaped it and of the history of human presence on a coastline that looked very different for most of the time people have been living near it. The findings are documented. They are published. They are real. And they have not been assembled in any single public account that gives them the weight they deserve. This is that account. If you are new here, this channel covers Australian history, science, and country that most people were never properly taught. Subscribe now and let me know in the comments below how many times you have visited the 12 Apostles and what you thought you were looking at when you got there. Let us start with what the 12 Apostles actually are and why the standard account of their formation is incomplete in ways that matter. The standard account is this. The cliffs along the Port Campbell coast are made of limestone. That limestone has been carved by the relentless action of the Southern Ocean over thousands of years. The sea attacks the base of the cliffs, creating caves. The caves deepen and eventually break through to form arches. The arches collapse, leaving isolated stacks standing in the sea. The stacks are slowly undercut and eventually collapse themselves. The whole cycle repeats, the coastline retreating slowly inland as the sea consumes it. This account is not wrong. It accurately describes the general mechanism of how the stacks form. The problem is that it treats the process as simple, linear, and primarily driven by wave action alone. The geology of the Port Campbell coast is significantly more complex than this account implies. The limestone that forms the cliffs of this coastline is not uniform. It was deposited over a period spanning from approximately 10 to 20 million years ago, during the Miocene epoch, when this part of southern Victoria was covered by a shallow, warm sea. The organisms that lived in that sea, including corals, mollusks, echinoderms, and the microorganisms that produce the fine-grained calcite that forms the matrix of the rock, accumulated on the seafloor and were gradually compacted into the limestone that is now exposed in the cliff faces. But the deposition of that limestone was not uniform. Different periods of deposition produced limestone with different compositions, different strengths, and different responses to weathering. The cliff faces at the 12 Apostles preserve a vertical record of those compositional variations in the distinct layers visible in the rock. Some layers are harder and more resistant to erosion. Others are softer and more susceptible to the chemical weathering by rainwater and to the mechanical attack of the waves. The pattern of erosion that has produced the specific forms of the stacks, their heights, their profiles, the spacing between them, is not simply the product of random wave action. It is the product of wave action interacting with a rock sequence of specific and variable composition. The geometry of the stacks reflects the geometry of the geological variations in the cliff, expressed over the thousands of years that the erosion process has been operating. The Geological Survey of the Port Campbell coast, conducted in detail by researchers from the Geological Survey of Victoria and from Deakin University and Monash University over the last 20 years, has documented the compositional variation in the cliff limestone with a precision that earlier surveys did not achieve. The documentation of the relationship between specific layers in the limestone and specific features in the coastal morphology, which stacks persist and which collapse, where arches form and where they do not, has produced a model of coastal evolution at this site that is significantly more sophisticated than the standard account. And that model has produced a finding about the rate of change at this coastline that surprised the researchers who produced it. The 12 Apostles are disappearing faster than anyone thought. Monitoring of the stack positions and heights using repeat photography, repeat survey measurements, And most recently, satellite-based monitoring technology has documented a rate of coastal recession at the Port Campbell coast that is significantly higher than the rates previously estimated from the geological record alone. The coastline is retreating. The stacks are being undercut. The arches connecting some stacks to the cliff behind them are thinning. This was not news to the people who had been watching the coastline. The collapse of one of the original stacks in July 2005, which was captured on film and produced wide media coverage, was not an anomaly. It was a visible and dramatic instance of a process that monitoring had been documenting at a slower rate across the entire coastline for years. What the detailed monitoring has established is that the rate of change at the 12 Apostles is not constant. It is accelerating. The rate of cliff recession documented in the most recent decade of monitoring is higher than the rate documented in the decade before it. And the factors driving that acceleration are not simply natural variation in wave energy. The Southern Ocean is changing. The wave climate of the southern Australian coast, driven by the westerly wind systems that circle the globe in the southern hemisphere, is the single most significant driver of erosion on this coastline. Those wind systems are responding to the changes in the atmospheric circulation patterns that climate research has been documenting across the southern hemisphere. The waves arriving at the Port Campbell coast are, in the assessment of the coastal oceanographers who have been monitoring them, becoming more energetic and arriving from slightly different directions than the historical record documents. More energetic waves attacking a limestone cliff produce more erosion than less energetic waves attacking the same cliff. The mathematics is straightforward. The implications for the future of the 12 Apostles are not comfortable for anyone who values this coastline as a stable landscape feature. The 12 Apostles as they currently exist are a temporary configuration of a coastline that has been in continuous change for the entire period it has been exposed to the sea. Previous configurations of this same coastline, which the geological record preserves, included stacks in different positions, arches in different locations, and cliff lines set further to the south in positions that the sea has already consumed. Future configurations of this coastline will not include the stacks that are visible today. The question is not whether they will fall. It is when. Now let us talk about the biology. Because the 12 Apostles and the broader Port Campbell coast are the site of biological communities of significant scientific interest that the scenic backdrop framing of this coastline entirely obscures. The marine environment of the Port Campbell coast is one of the most productive in southern Australia. The cold, nutrient-rich waters of the Southern Ocean support communities of marine life of exceptional diversity. The rocky reef systems that extend from the base of the cliffs and from the submerged foundations of the stacks into the deeper water offshore are among the most biodiverse temperate reef environments in Australia. Research by marine biologists from Deakin University and the Victorian Government's Department of Environment, Land, Water and Planning has documented the reef communities of the Port Campbell Marine National Park, which encompasses the waters around the 12 Apostles, in increasing detail since the park's establishment. The findings from those surveys reveal a marine environment of greater biological richness than the comparable surveys of other Victorian reef systems outside protected areas. The protection provided by the marine park, established in 2002, has allowed the reef communities within it to develop in ways that demonstrate the ecological difference between protected and unprotected reef systems. Fish populations within the park are measurably larger and more diverse than fish populations in comparable reefs outside the park boundaries. The invertebrate communities on the reef surfaces show higher diversity and higher biomass within the park. What this comparison establishes is not simply that the 12 Apostles marine environment is biologically significant. It establishes that the ecosystem that would have existed on these reefs before European fishing and coastal modification is significantly more productive and more diverse than what exists in unprotected Victorian waters today. The baseline that the marine park is restoring toward is an ecological state that no living person has observed. It is a state that existed before the industrial-scale exploitation of this coastline's marine resources began in the 19th century, and that is only now beginning to reassemble itself within the protection of the park boundaries. The biological surveys of the marine park have also produced species records that were not expected from this coastline. Deep water surveys using remotely operated vehicles have documented species assemblages at the base of the stacks and in the deeper water offshore that represent the first confirmed records of those species from Victorian waters in several cases. The water beneath the 12 Apostles is biologically richer and more surprising than the view from the clifftop lookout suggests. Now let us talk about the cave systems. Because the cliff faces of the Port Campbell coast contain cave systems that are significantly more extensive than the tourist perspective from the clifftop reveals, and those cave systems have their own scientific story. The caves carved by the sea into the base of the Port Campbell cliffs are not simply empty holes in the rock. They are environments with their own biological communities, their own physical conditions, and in several cases their own geological features that differ from the exposed cliff faces above them. The cave interiors are protected from direct wave action for much of the time, creating conditions of lower physical disturbance than the exposed rock surfaces. In those lower disturbance conditions, specific biological communities of marine invertebrates and encrusting organisms have developed that are not found on the exposed surfaces above. The Biological Survey of the Accessible Cave Systems along the Port Campbell coast has documented communities that represent some of the least disturbed examples of these assemblages remaining in Victoria. The geological features preserved in some of the cave interiors are also scientifically significant. Speleothem formations, stalactites and stalagmites of calcium carbonate, have been documented in several of the sea caves at sites above the current high tide level where the dripping of calcium-saturated groundwater through the cave roof creates conditions for carbonate deposition. These formations are not large. They are not the dramatic cave decorations of a limestone cave system, but they are chemically distinct from the surrounding marine environment, and they provide a record of the groundwater chemistry of the cliff above them that has not been systematically exploited as a research resource. The caves are also relevant to the human history of this coastline. In the context of the sea level history of this region, the caves and the ledges and the sheltered spaces in the cliff base represent the kind of environments that people living on this coastline before European settlement would have used and would have known in detail. Which brings us to the most significant finding from this coastline that no visitor standing at the lookout is told about. The human history of the Port Campbell coast extends back to a period when the coastline looked nothing like it does today. The sea level along the southern Australian coast at the last glacial maximum, approximately 20,000 years ago, was more than 100 meters lower than it is today. The coastline at that time was approximately 60 to 80 kilometers south of its current position. The landscape that is now the seafloor between the present cliff line and the old coastline, the continental shelf that the Southern Ocean now covers, was dry land. Land that people walked on. Land that people lived on. The people who inhabited the coastal margins of southern Australia during and after the last glacial maximum occupied a coastal zone that is now entirely submerged. Their campsites, their middens, their evidence of coastal resource use, their hearths and their stone tools, are all underwater. They have been underwater since the sea rose following the end of the glacial maximum, starting approximately 15,000 years ago and reaching approximately its current level around 7,000 years ago. The Marine Archaeological Survey of the continental shelf off the Port Campbell coast, conducted by researchers from Flinders University and from the University of Melbourne as part of a broader program to investigate the submerged landscapes of the southern Australian margin, has located sedimentary sequences on the shelf that preserve the remnants of the terrestrial environments that existed on that land's surface before the sea covered it. The sequences contain pollen, charcoal, and in some cases the remnants of plant material that document the vegetation of the pre-submersion land surface. The charcoal in those sequences indicates the presence of fire, and fire in this context means people. The pollen sequences document vegetation changes that the research interprets as consistent with human landscape management of the type that has been documented at other sites where the evidence of Aboriginal burning practices is preserved. People were living on land that is now 60 to 80 kilometers offshore, on a surface now covered by more than 100 meters of water, and managing the vegetation of that landscape in ways that left a chemical record in the sediment that the underwater surveys have recovered. The Aboriginal history of the Port Campbell region is not the history of people living on the current coastline. It is the history of people living on a coastline that no longer exists at the surface, whose traces are preserved on the sea floor in sediment sequences that the research of the last 2 decades has been progressively recovering. The traditional knowledge of the Maar people and of the Eastern Maar Aboriginal Corporation, whose country includes the Port Campbell coast, encompasses the full history of their relationship with this landscape across the entire period of human presence. That relationship predates the submersion of the old coastline and encompasses the changes that the rising sea imposed on the landscape and the communities living near it. The traditional knowledge of what the coastline looked like before the sea rose, and of the places that are now underwater that were significant in the period of lower sea level, is encoded in traditions that the research community is only beginning to engage with as a serious source of information about the submerged landscape. This is the same pattern that appears at every site in Australia where traditional knowledge and scientific research have been brought into genuine dialogue. The knowledge is accurate. The science confirms what the knowledge describes. Now let us bring the full picture together. The 12 apostles are changing faster than the previous understanding of coastal erosion rates suggested, driven by an accelerating wave climate that reflects the changes occurring in the Southern Ocean's atmospheric circulation systems. The marine environment around them supports a biological community of exceptional richness that is only now beginning to recover within the protection of the marine park toward a baseline ecological state that predates European exploitation. The sea caves in the cliff base contain biological and geological records that have not been systematically investigated. And the human history of this coastline extends back to a period when the coast was 60 to 80 kilometers south of its current position, on land now covered by the sea, in a landscape whose traces are being recovered from the sea floor by underwater surveys that are still in their early stages. The 12 apostles are not a stable scenic backdrop. They are a rapidly changing section of one of the most energetic coastlines in the Southern Hemisphere, sitting above a biologically remarkable marine environment, adjacent to a submarine landscape that carries the physical record of the oldest human history of this part of Australia. The people who stand at the lookout for 20 minutes and take photographs and drive on are seeing the surface of something that extends in every direction and into the recent and deep past in ways that 20 minutes at a lookout cannot convey. The stacks will fall. The cliff will retreat. The coastline will be different. It has always been different. And the sea that is changing it has been changing it since long before anyone stood at a lookout to watch. If this changed how you think about the 12 apostles and the Great Ocean Road, leave a comment below and subscribe for more Australian history and science that most people were never properly taught.